Good day and welcome back. I'm just gonna give 2 minutes to those who are still trying to join, and then um and then after that we can start. But in the meantime, what you can actually be doing, you can actually try and make sure that at least you are busy with this homework if you haven't done so. And then there's also some of the questions that were not part of the homework, so you can be busy with that. And then we'll continue. Just give 2 minutes. Yeah, for those who are still trying to join, and then we'll start. Okay. Found the earphones. Ndifuna ufaka apha. Ndifuna ubona le nto uba iyabonakala na. Okay. Siyabheka wathi ndiqhube neklasi yam. Zisebhakeni. Okay. Let us start and see how we actually can solve these problems. Okay, guys. Those who are struggling to join, I think it's just a technical error because I keep accepting students this side, but I don't know what is happening. So I will just record the lesson, and then at a later stage they will be able to look into it because I can't. There's nothing that I can do on this side. Let us start and see if you actually got the answers right when it comes to this homework here. So we had this one here. What's happening here? Is this? Oh, we're doing this one. Okay, and then what else do I need? I think I have everything that I need. So, yesterday we were talking about decimals, and we said that decimals is a way of writing numbers that include a decimal point to show values that are less than 1. And we also said that it is part of the base 10 number system, which means that we want to write this. When we want to write these numbers in a decimal form, we want to use the base 10 number system. So that is what is happening. And also another thing, that base 10 is actually telling us that the number that is less than 1, we want to compare it to the to 10 to some powers there. That is actually the powers that we're using are actually determining the decimal point. But that is actually not that much important because what is important is that can you convert in between two numbers? Okay. Yeah. Can you convert between two numbers? So if, let's say, now we wanted to convert or express these fractions as a decimal, there is a certain way that we did it. And also if, let's say, we're given a decimal, we can actually convert it to a fraction. And we took an example, and then we said that, let's say we have 2,12, and if you wanted to convert this to a fraction, we said that the best way to do it is to first convert it to a mixed number or a mixed fraction. And then how do you do that? This number here that is before the comma, you say that that is our whole number, and then in the numerator you take this number after the decimal, you place that 1 2 there, and then after that you have a 1 in the denominator, but you need to add some zeros there. So the number of zeros is determined by the number of numbers after the comma. So here the numbers that we have 1 and 2, so we have 2 of these numbers, so we're supposed to end up having 2 zeros. And that definition, when we are saying that a decimal is actually part of the base 10 number system, if you look into this 100 here, you can see that this 100 is the same as 10 to the power 2, which means that we have two numbers after the decimal. That 2 is actually saying two numbers, and then after that, if you take this and you simplify in a calculator, you're actually getting this. So that base 10 system is actually talking about this 10 here. So we're actually using a 10 to convert these numbers. And then after that, of course, to convert this to a proper or improper fraction, all you do, you multiply this whole number by 100, and then you get a 200. So you have your 200, and then you plus this 12 here, which is in the numerator there, to get the numerator. So 200 plus 12, that is going to be a 212, and then you actually divide by the same denominator that was here, which was 100. So that was what we're actually doing. And also, if you wanted to convert this back to that, we said that you ask yourself how many 100 are contains in 212, and 212, you can see that we have 200. So you place a 2 here, and then you place a comma or a dot or a decimal point there, and then after that you say that okay, here you will end up having a 12 as a remainder. And then after you've placed that comma there, you add a 0 in that remainder, so you end up having a 120. You ask yourself how many 100 are in 120, and then after that you can see that you have 100 in 120, so you have 1 there, and then after that you will be left with a remainder of 20. So you add a 0 in 20, and then you ask yourself how many 100 are in 200, and then you can see that there are 2, and then there is no remainder. That's what we're actually doing yesterday. We're going back and forth, and then I left you with this homework here. Of course, I will try and make sure that I'm fast as possible. So the first thing that you do here, if you want to convert it to a decimal, you ask yourself how many 8 are in 7, and you will see that 8 is bigger than 7, so there is no way that you can get an 8 in 7. So there are 0, 8 in 7, and then after that you place a comma there, and then you add a 0 in that 7, and then you ask yourself how many 8 are contained in 70. So if you wanted to find how many 8, of course most of us are already having a calculator. Some of us know the factors, the multiples of 8. Some of us don't. But if you don't know the factors, the multiples of 8, you can say that, okay, the first one is going to be 8, and then you can see that you will end up having an 8, and then you add an 8 to get the second one. You get a 16, that's the second one. The third one is going to be a 24. The fourth one is going to be a 32. The fifth one is going to be a 40. And then the sixth one is going to be 48. And then you continue to do this. You end up having 56. From 56, you end up having a 64. And then from 64, you end up having a 72. So if you look at 72, 72 is bigger than 70. So what we are actually looking for here, you can see that in this 70 we can get 64. In other words, we can get 1, 2, 3, 4, 5, 6, 7, 8. So we can actually get 8 out of 70, and then you will be left with a remainder. So the 8 is going to actually say that we will end up getting a 64. So you just say 72, 70 minus a 64, and then what you will end up getting here, you will end up getting a 6 as a remainder. So after you have divided 70 by 8, the remainder is going to be a 6, and then after having a 6, you add a 0 there, and then you ask yourself how many 8 are in 60, and then you can see that 60 is actually just between 56 and actually 64. So we have how many 8? 1, 2, 3, 4, 5, 6, 7. So we're actually going to end up having 7 8 in 60, and then what will be the remainder? The remainder is going to be a 60 minus 56, and then the remainder is going to be a 4, and then in that form you can see that you need to just add a 0 there, and then you ask yourself how many 8 are in 40, and then you will see that actually this is the 40. So to get the number of 8, you will end up having 1, 2, 3, 4, 5. So we are actually having 5 8s in 40, and there is no remainder. The remainder is 0. So what we were looking for in this particular problem is that this is the answer that we were looking for. And then you do the same thing here, that you ask yourself how many 10s are in 8, and you can see that 8 is bigger 10 is bigger than 8, so you will end up saying that there are no 10s in 8. So you place a 0 and you place a comma there, and then after that you add a 0, and then you ask yourself how many 10s are in 80. So you'll find out that we have 10, 20, 30, 40, 50, 60, 70, and then you end up having an 8 here. That is actually what is important here. And then once you have that, you will find out that you go here. There is also something else here that you can actually do if you don't want to deal with this, because there is a common factor between 8 and 10. So the common factor is 2, and you know that there are 4 2's in 8. And then after that, you can ask yourself how many 2's are in 10. And then what you actually do, you end up saying that, okay, I will end up having 4 over a 5. So you will end up having 8 over 10 is equal to 4 over 5. And then after that, you can actually say that, okay, how many 5 in 4? You can see that you don't have any, so you end up having 0 comma. And then after that, you can add a 0 there, and then ask how many 5s in 40, and then you'll find out there are 8 of them. So you can either reduce this, or you can just deal with it directly. You're still gonna get the same answer. And then when it comes to this one here, you just ask yourself how many 10s are in 11. You find out actually that to find the number of 10s in 11, I have 10. So there is 1 10 in 11, I can get it. And then after that, I will get a remainder. So to say that there is a remainder, I place a dot there, or a decimal point. Okay, that's it. And also in a calculator, it is this, so it is just a dot. And then after that, the remainder is going to be 1, and then I add a 0 in that 1 there. And then I ask myself how many 10s are in 10, and then you find out there is only 1 and there is no remainder. So this is the answer we're looking for. And then with the number D, you ask yourself how many 100 are contained in 3. So you find out there are 0 of them. So, and then I add a 0 there. Whenever I'm adding a 0, I place a dot there, or a decimal point. And then I ask myself here, how many 100 are contained in 30? You find out actually 100 is bigger than 30. So I end up saying, okay, there are 100 out of 30. Now, I don't place another comma here because a decimal must have only 1 decimal point or 1 dot. You get what I mean? So I hope you can see that when I'm actually now dividing 30 by 100, I just place a 0 to say that there are no 100 out of 30. And then after placing this 0 here, I also place another 0 here, and then ask myself, how many hundreds are actually contained in 300? And then you actually end up finding out that you are actually having 3 of them, and there is no remainder. So that is what we are looking for here. I hope you got all this the right way. If you don't get them, you can raise your hand and say that you are not getting it. Anyone who's not getting it up to this 4, Solomze? You can unmute yourself and then say what you want to say. Number? Number D. Oh, here. Okay. Here, you number D. Let me restart. I'm not really getting the the question, but I will try and see if maybe by just responding I will be answering your question. So what we are saying here in number D is this. So the first thing that you ask yourself here is this: how many hundreds are contained in 3? Can you take 100 out of a 3? So if you can't, you just say, okay, I am going to say it is 0. So I have 0 of these, and then you place the comma there or the dot. And then once you place that comma there, you add a 0 in this tree, so you end up having a 30. And then you ask yourself, is this okay? Just to make sure that, guys, we don't end up missing a class, try to be early as possible, because sometimes it's hard to accept these things. Maybe the network is slower on your side, so when I'm accepting it, it's not going through. So let's try and be early, maybe 5 minutes, so that at least someone can try and log in as early as possible. So the first thing that we said here is this. So we're actually saying that whenever you have a tree, you ask yourself how many hundreds are contained in tree, and then you say there are 0 of them. Because this is the first 0 that you have, you place a comma there, and then after that you add a 0, and then you have a 30. So you end up having a 30 divided by 100. So you have a 30 divided by 100. So if you want to, you can say that, okay, now that I'm dealing with this, I can either cancel a 0 and a 0 and say how many 10s are contained in 3, or end up saying that, oh, this is just 3 over 10, and then you ask yourself how many 10s are contained in 3, and you find out actually that there are no 10s contained in 3. So since there are no 10s contained in 3, you just place a 0 there to say there are no 10s contained in 3. And then after that, we were supposed to follow by a comma, but we already have this comma here, or this dot here. And then what you do, you just place a 0 alone, and then you add a 0 there, and then you ask yourself how many 10s are contained in 30, and then you find out actually that there are 3 of them. I hope I've answered your question, because even in this case there are no hundreds there, so you end up placing this 0, and then you add a 0 there, and then you ask yourself how many hundreds are contained in 300, so you end up having that. So that's how you end up doing this whole thing. I hope I've answered your question. Any other question? Or if I haven't answered your question, you can still ask where are you actually having a confusion, so that we can move forward. Okay. In the absence of questions, I'm going to move forward. So the next thing that I want us to actually deal with now is, I want us to convert this to a decimal, these two, and then there is something special about these two. So if, let's say, you wanted to find out this in a decimal form, what you do, you ask yourself how many trees are contained in 1, and then you know that there are actually 0 trees contained there, because this is the first 0, so you place a comma there. And then the next thing that you ask yourself, you just be like, okay, I placed it a comma, I placed a 0, so I add a 0 there. And then I ask myself, how many trees are contained in 10? So you find out we have 3, 6, 9, and 9 is still less than 10. So we have 3 trees that are actually in 10. And then once I divide by 3, I will be left with a remainder, which is a 1. And then once I have that remainder, which is a 1, I add a 0 there and ask myself how many trees are contained in 10, and you will find out actually that there are 3 trees that are contained in 10, and then the remainder is going to be a 1. And then I ask myself again, because I've placed this 3 now, I add a 0 there and I ask how many trees are contained in 10. You will find out that there are 3, and then the remainder is 1, and then I add a 0 in that 1, and then I ask myself how many trees are contained in 10. You'll find out I will have a 3, and the remainder is still gonna be 1. So I will end up having so many trees going all the way I will end up having so many trees. So to say that I will end up having trees throughout, I usually place 3 dots there. So there are 3 dots to say that these trees will continue. So I'll end up having 0.33333333333 so many of these trees. And another way to rewrite this, that this is actually continuing and it is a decimal that is not terminating, we usually write it in this form to say that I have a 0,3, and then all the numbers that will be following this tree. So if I keep continuing and adding a tree, I will keep having tree throughout. So here I end up placing a bar. So that bar there is telling that after this tree, I will have trees, so many trees, and I'm not going to stop. I will keep having a tree after tree after tree. So that is what is actually happening with this particular example. And then another way that other people usually use, but for me I usually like this one, they usually say it's 0,3 and they place a dot there to say that it's 0,3 throughout. So that is what is usually happening with this particular example. And then for this one here, anyone who wants to try? Anyone who wants to try? Okay, do you get number E? Just press a thumbs up if you are getting it. Okay. Okay, Nonke, can you say what you want to say? Unmute yourself and then I think you have a question. Nonke. Nonke, please unmute yourself and then you can say what you want to say. I can see that you are raising a hand.
Hayi sendifumene le nto bendizoyibuza.
Okay, sure.
Sendiyibonile.
Okay. Let us look into this one now. Okay. This one here is saying that we want to find out how many trees are contained in 2. So there are no trees contained in 2. So you just place a 0 here, nice 0 and a comma or a dot or a decimal point. So if you look into this, the reason I usually say a comma is because sometimes you find out a calculator, instead of having a dot, it has something like this, a comma like this. So it's not like others they are using this, others are using a dot, but it just means the same thing, that we are actually having a whole number this side and everything that side which is less than a 1. And then here there are 0 2s and the 0 3s out of this, so we end up adding a 0 and then we ask ourselves how many trees are contained in 20. So to get how many trees, you just say 3 6 9 12 15 18. So we have 6 of them, and then the remainder is going to be a 2, and then you add a 0 here, and then you ask yourself how many trees are contained in 20. You find out there are 6 again, and then this one here, the remainder is going to be a 2, and then you add 1 0 there, and then you ask yourself how many trees are in 20, and then you find out that there are 6, and then the remainder is going to be a 2, and then you add a 0, and then you find out there are 6. So you will find out that the remainder is always going to be a 2, and then you will keep continuing and have these 6 throughout. So if you don't want to write all of them because you're not gonna finish, you just place 3 dots at the end, and this is actually the same as just saying I have 0,6, I have 0,6, and then I have a bar there or a dot to say that every number that is following the 6 is going to be 6 throughout. So this one here is writing the exact number. What is that number? I don't want you to say that, no, sir, this one is supposed to be 0.3. I have rounded it off. I've rounded it up, whatever. We're not rounding off anything here. We are actually writing this thing as it is. So this thing here is actually saying these things here. So it's still the same thing. It's not an approximation. So this bar or a dot, you can say 0.6 and place a dot. It's just saying that I have 0.66666 throughout. And then if, let's say, now I give you some of the other examples here just to emphasize the meaning of the notation here. So if, let's say, I'm saying 0.4 and then I place a bar here, what I mean, this is the same as 0.4444. So I'm going to continue writing this 4 and I'm not going to stop. So I have these 3 dots to say this. And then at the same time, if I'm saying I have a 0, let's say I have 0.285 and then I have let's say I have 714. This is a random number, and then I place a bar throughout. So if I'm placing a bar throughout, it means that this is the same as 0.285714, and then this number starts to repeat again. So I'm going to actually end up having 285,714, and then it repeats again 7. It repeats again, and then it starts at 285,714, and then it continues forever. So what if you look into this number here, it is the same number as that, it is the same number as that. So when I'm placing that bar, I am saying repeat this number after it and then keep repeating it throughout. And then if, let's say, I am giving you, let's say 0.83, so I'm giving you 0.83 and then I place a bar here only. So this is just saying that this number is same as 0.8, and then I have a 3, and then after 3 I keep repeating the 3. That's what this notation is actually meaning. So I keep repeating the 3 throughout. So the bar, when it is only there, it continues. And then if I have 0.63 and then I have a bar like this, is saying that I'm going to have 0.63 and then I repeat this whole thing after it. I'm gonna keep repeating this. So I'm going to have 63 and then again 63 and then again 63 again 63, and then I'm gonna continue in this particular fashion. So that is what is actually happening here. So if now I am actually saying 0.123 and then I am having this, this is actually meaning that we are actually having 0.123 and then I'm repeating 123 and then I'm repeating 123, something like that. And if I'm having 0.123 and then I have this piece here, this simply means that now I will end up having 0.123, but after this number here, after this number, I keep repeating only these two. So I will end up having 23, 23, 23, and then I have my 3 dots. So that is how we actually having this notation or using that particular notation. But if I am saying you have 0.123 and then I have a bar here and a bar there, what does this mean? This is not allowed. This cannot happen. So we only have one bar in the numbers that are repeating, right? If, let's say, I wanted to say, I want you to write 0.123 and then I have 1 3 and then 1 3 and then 1 3 and then 1 3 throughout, I don't write it like this. So the first thing that I just do, I write 0.123 and then after that I can just say, if you notice here, this number here, I can write it maybe up to this far here and say I have 3 and then I have 1 3, and then after that I can just place a bar to say that after this everything keeps following 1 3 1 3 1 3 1 3. So this can be written in this format. And of course, whenever you have something of this nature, this is the same as 0.63, and then to just say the bar starts here and ends there, and you want to use dots, it's a dot here and a dot there. That's all there is to this. And also for this one, you're just gonna place a dot, and a dot to say that I'm repeating all of them. And also there is no such a thing as I'm going to say 0.1 2 3, and then I have a dot here and a dot there. Some people are usually taking chances, so there is no such a thing. We usually place dots throughout, or dot in one that is being repeated. Anyone who doesn't get this one, so that we can actually start moving to the addition of decimals and subtraction. Do you get it? One thing that is nice, when I was still a student too, I would say I get it, so that we can move forward. Okay, that's great. Now I want us to actually talk about the addition of decimals. So to actually follow this, there is a nice algorithm that you actually follow, but I'm gonna do that by using some examples here. The task that I'm going to give you when it comes to this is this. I want you, because this is what we will do next week. I think next week is either Wednesday or Thursday next week. If, let's say, I am giving you a decimal which is 0.33333333 or 0.6 66666, and then it continues forever. Or I have 0.123 123, and then it continues. Or I have 0.8, and then I have 6 6 6 6 6 6 6 throughout. So 6 continues. Can you convert this to a fraction? Because this is a decimal. Can you convert this to a proper fraction? That is the task that I want to give it to you. Try and see if you can deal with this. We'll do it later. Not today, but next week. Try and see if you can actually convert this to a fraction. Of course, what is nice about these things is that most of the time when we are dealing with this addition of decimals, you can do that with a calculator. Calculator is going to give you the right answer. But now what is important here is not the final answer, because if, let's say, I am giving you questions as a multiple choice, just use a calculator, man. You have the calculator. For instance, if you look at 0, let's say I have I wanted to say that I have a 0 and then I have 1/2. Yesterday I said this is the same as just 1/2. How do you know that is true? You can test that with your calculator by just pressing this thing here that is sitting here. You have this thing here, and then you have this one here, and then you have that. So if you're looking close to this button here, you have something that is written like this. So if you are looking in this calculator here, this is actually telling you something like that. So if I just press here, it's going to just give me this thing here in a fractional form, not a mixed number. But here, there is something here which is saying that I have a mixed number. So if you wanted to actually show that up, all you need to do here, you press a shift, and then after pressing a shift, you go there, you will see it coming out. And then you have something nice, and then you have 1/2, and then of course it is the same as a 1/2. So that is how you actually pick this thing up. I hope you actually get that, because it is important when you're using multiple choice questions. But when you are given long answer questions whereby you are given a space to write, it's not a multiple choice question. we want you to write every single step. If you only write the answer, you will get 1 mark out of 5 or out of 4. But if you are writing all the steps, you will get the full marks. The good thing about this is that you can write some few steps and find out actually that the steps were fine, but you made a mistake in the final answer. So you might end up getting a 4 out of 5, and then you lose the 1 mark for the final answer. But if you just write the answer, you will get a 1 mark, just a 1 mark. So just use a calculator when you're using multiple choice questions, and also try to use a combination of a calculator and the principles when you are writing a long answer questions. So as much as this thing looks so much tedious, but it is actually important for actually the marks. Sometimes I do usually prefer the long answer questions, because long answer questions, even if your answer is wrong, you might end up getting a 1 or 2. But a multiple choice question, if the answer is wrong, you're just wrong. So try and make sure that you get the principles. So what we're actually going to do with this example is this. I want us to evaluate with and without a calculator, evaluate the following sums. So the first one is going to be, I have a 2.12, and then I have a plus, I have a 3.34. And then how do you end up adding this decimal here? So what is important here is very simple, that to actually add this whole thing, the first thing is, don't waste your time, just press it in a calculator that you have 2.12, and then you add 3.34, and then you're actually gonna end up having something like this. So this is a fraction, and then after getting this fraction here, you can press this this symbol here. So when you're pressing this symbol, it's going to actually give you the actual answer, which is just equal to 5.46. So if you are using a multiple choice question, you can just do this and then don't waste your time and then get this, so that you're fine. Use your calculator. But if you are answering a long answer question, what I'm expecting from you is this. First, write this as it is. So you end up saying that I actually have 2.12, and then after that you write this whole thing underneath. But before you write it, write this decimal point here, just before the decimal, just below the decimal, the decimal point. So this must be in line, and then after the decimal you have 34, and then before the decimal you only have a 3. So how do you end up adding? You place this one here which says that you are adding. You say 2 plus 4, you have a 6, and then 1 plus 3, you have a 4, and then a dot, and a dot is just a dot, and then a 2 plus 3 is just a 5. You can see how easy this thing is. And then let's take another example here, B. Of course, you can press a calculator and get the answer. 2.3 plus 0.34. You can press a calculator. The calculator is going to give you an answer, but we're not interested in that because you can do this by hand. First thing, you write this as it is, 2.3, and then after that you write this underneath, and then you write these numbers after the dot there. So the first number after the dot is a 3, and then the second one is going to be a 4, and the number before the dot is just a 0, and then I have a plus there. I place a line there to say that I'm about to add, and then I want to add a 4 here, but there is nothing here. So when there is nothing, I place a 0. 0 plus 4 is just a 4. 3 plus 3 is a 6. A dot and a dot is a dot. A 2 and a 0 is just a 2. So that is your final answer, or you can just press it in a calculator. 2.3 plus 0.34. So if you are actually having this here, you will actually end up finding something of this nature, which is that. And then let's try and do number C. Number C is saying that we want to actually add some nice numbers here. I'm just gonna do this one and then give you 2 as your task. I have 0.06 and then plus this one I will give you as a classwork. So we have 245 0.8794, and then I want to add this with 356.376, and then I have a 1 there. So I wanted to add these 2 decimals. So the first thing that I wanted to do here, I want to write this as it is. So I have 2 4 5, and then I have this decimal point there, and then I have an 8, I have a 7, I have a 9, I have a 4, and then I wanted to write this number underneath. So before I place a plus, I wanted to start with this dot here. So I place a dot, and then I write a 3, I write a 7, I write a 6, I write 3 7, I write a 6 just below 9, I write a 2, and then I write a 1 there. And then before we had a 6, we have a 5, we have a 3. So we want to add these 2 numbers, then I place a plus there. Because there is nothing there, you place a 0. 1 plus 0 is just a 1, or 0 plus 1 is just a 1. And then you have a 4 plus 2 is just a 6. And then a 9 plus 6, what is 9 plus 6? Is supposed to be a 15. So you write a 15 like that. You cancel this 5 here, and then you place it there. You cancel this 1 there, and then you place it there. And then you say 1 plus 7 is 8. 8 plus 7 is 15. Or you can say 7 plus 7 is 14. 14 plus 1 is a 15. So I have another 15. And then I cancel the 5. I place it here. And then I cancel this one. And then I donate it here. So when you are donating, you just say 1 plus 8 is going to be a 9. 9 plus 3 is going to be a 12. So you have a 12 there. And then I cancel a 2. I'm going to place a 2 here. And then I cancel this one, and then I donate it there. This decimal is this point here is not a number, so I donate where there are numbers. So a decimal point and a decimal point is just a decimal point, and then 1 plus 5 is just 6, and then 6 plus 6 is a 12. I place a 12 there, I cancel a 2, and then I place a 2 there, and then I cancel a 1, and then I donate. And then 1 plus 4, we know that is a 5. 5 plus 5 is going to be a 10. I place a 10 there. I cancel a 0. I place a 0 there. And then I cancel a 1. And then I donate it there. And then I ask myself, what is 1 plus 2, which is 3. 3 plus 3 is going to be a 6. So I end up placing a 6 there. And then there's nothing else. There's nothing to donate because 6 is just a 1 number. So that is actually what we are having here. Now I wanted to give you an example and an exercise, not an example. I want you to find 0.06 plus 0.004, and then I also want you to find 12.345, and then I want you to add 7.655. Can you try and do that? Try and do this example here. These examples. I will give you 5 minutes to complete this. So now we are at 21 and 25. We are stopping, and then we are going to the subtraction of decimals. If you are done, you can tell me that you are done so that you can move. Two are done. Okay, three. Okay, so let us try and see there's one thing that I wanted to specify before doing this. If let's say you want to add, I'm not going to add it, I'm just gonna tell you what is happening here. This is based on what I said yesterday. If let's say you want to add one, let's say 1 7 3 4 plus 2 3 4 9 1, I have 1 2 3 4 5. Okay, now that we are actually having this here, what is happening is this. Let's say you wanted to add these two numbers. There are 4 numbers here, there are 5 numbers there. Yesterday I said that this number here, if there is no decimal place here, it is the same as just 17 34, and then you can place some zeros at the end because zeros are just nothing. And then this one is the same as 2 3 4 9 1, and then you can add some zeros. It doesn't matter how many of them because it's just a zero. Zero is not adding anything. So what I actually said now is that when you want to add these two things, you first place write this number as it is. So you will write 17 3 4, and then you place the zeros that you have. You have a comma and then you place zeros. It doesn't matter how many zeros you place. And then when you are writing this number, you have to start with the with this dot here, and then you can see that I have zeros. Even if you place 10, the dot, these decimal points needs to be there. They need to be aligned. Lisakanya, please. Please unmute yourself. Lisakanya. Yeah. So you end up having this, and then you start writing these numbers, and then you end up having 1, and then you have a 9, and then you have a 4, and then you have a 3, and then you have a 2 there. So that is why yesterday I was saying that when you want to add these numbers, you always start like this. It's because the rule is just saying make sure that you align the decimal point with each other, and then you start writing all the numbers that are before and all the numbers that are after. Because 0 means nothing, so I can remove the zeros and say when I want to add, I will just start adding like this. And then where there's nothing, I'm going to put zeros, and then I add, and then a 4 is going to be 5, and then I continue all the way. So that's what I was saying yesterday, to make sure that when you're adding these numbers, you don't end up saying you put a 1 here, a 7 here, a 3, and then you have a 4 somewhere there. No, you don't do it like that when you're adding. You start this side. Let's do this one now as it is. So we said that you have 0,06. You start by writing it, and then secondly, you write this dot just below this dot here. So this was a 0, and then after that you have for this one here, after this dot we have 004. So I have 004, and then before the dot I just have a 0 and a plus now. So because there is nothing there, I add a 0. 0 plus 4, I have a 4, and then 6 plus 0 is just a 6, and then 0 plus 0, I have a 0, and then 0 plus 0, I have a 0. So that is actually what is happening there. So this is the answer to that, or you can check it with a calculator that you have 0.06, and then you have plus 0.004. you can see that what you are actually getting is 0.064 or just 0.064. So this is the answer to this question. And then for this one, of course, you're just gonna write 12.345, and then you start with this decimal point here, and then after that you write the numbers that are after a decimal point, which is 655, and then before that, you know that you only have a 7 and you don't have anything before 7. So 5 plus 5, we know that it is a 10. Okay, we have a plus here because I'm adding. We have a 10, so you cancel this 0, you place a 0 there, and then you cancel this 1, you place it there. 1 plus 3 is 4. 4 plus 6 is 10, so you are having a 10 there. So you cancel this 0, and then what did I do? I jumped here. So this one was supposed to be donated here. This one here, so we're supposed to be here. So 1 plus 4 is 5. 5 plus 5 is 10. So I have a 10, and then I cancel this 0 there, and then I'm going to place a 0 here, and then I cancel this one, and then I donate it there. And then I ask myself, what is 1 plus 3? 1 plus 3 is 4, and 4 plus 6 is 10. So I have a 10. I cancel this 0, I place it there, and then I cancel this one, and then I donate it here. I don't donate it here because these are decimal points, or not numbers. A decimal point and a decimal point is just a decimal point. And then 1 plus 2 is 3. 3 plus 7 is 10. So I'm going to cancel this 0 here, and then I place it here, and then I cancel this one, and then I donate it there. And then I have 1 plus 1 is 2. 2 plus 0 is still a 2, and then it is just a 1 digit. So this is actually 20.00, or just 20, because these zeros are not adding anything. Or you can just try and check it here, which is 12.345 plus 7,655. Yeah, 7. We have a point there. 655, so this is a 20 like we got it here. So 20.00 is still the same as just a 20. I hope you get this, because I want us to actually look at the subtraction of decimals. Subtraction of decimals. So I will try and make sure that we spend some time here, because subtraction of decimal is not as easy as adding them up. Subtraction is always an issue, as you have seen when you are subtracting numbers, that sometimes you get a negative, sometimes you get a positive, and you don't know what is basically happening. So I want to start with this, but before I do that, anyone who have a question, you can unmute yourself and then say you have this question. Okay, I assume that there is no question there. So if there is no question, I assume everything is actually going well. Yeah. When I was still a student, for me, what was hard is, I think English was a problem for me. Until I actually started to do my honors, it was actually a big problem. I didn't want to speak it. I hated it. Until someone told me something that was important, that just go to YouTube and then look at just random videos, and then you just watch them. You will see what is going to happen. People are breaking it piece by piece, but because of confidence, no one is actually going to see that this person is actually breaking English. So it is always important for you, if you wanted to get it, just try and speak it anyhow. Even if you are just saying that today I went to town, or today I went to town at 5:30 afternoon. We know that Went is trying to tell something. So just don't mind English. English in a maths class is not a problem. It is really not a problem, because sometimes it is actually contradicting with maths. So in a maths class is actually not a big problem. And also another thing, you shouldn't be so much concerned about how broke your English is, because at the end of the day, English is also evolving. There are so many investigations that are happening. There are so many new things. So making a fuss about my English is broken, this person is going to laugh at me if I'm saying it like this. If someone is laughing at your English, trust me, the reason they are laughing at you is because you are not alone. There are things that they also don't understand. They don't know how to speak. So just speak your English, as broken as it is. The more you speak it, the more you will actually learn. And also, if you want to improve on the words, start reading. Start reading. The more you read, and stop these soapies. You see these soapies that we are watching that are actually in Xhosa or Zulu or whatever. If you still wanted to learn English, stop watching those things. Watch things that are actually in English so that you can keep learning. Uzalo masuliyeke nezinye masiyekwe nifocus kulezi. Yazibona lezi zine English. I'm supporting Amandia. If you wanted to learn more, you can watch these Indian movies, Indian soapies. You will be fine. In the meantime, let's keep breaking it, guys. So what is happening here? I want all of us to study this subtraction of decimals. So we studied. That's what we are going to do here. Subtraction of these decimals. So any questions so far? I think all of us are fine. Okay. If let's say you wanted to add, what is actually happening? You write something on the top and then the other on the below, and then after that, of course, if you actually wanted to subtract, it's still the same thing, but you want to make sure that the decimal point is actually aligned. So I'm going to end up having some few examples here to do this so that we can get it. So we have A. I want us to add 0.9 minus 0.4, and then after that I want us to add this is going to be our B, 5.75, and then we subtract 2.25, and then from there I want us to have C, and C is going to be 3.5, and then minus 1.75, and then from there I want us to do some D, and then D is going to be 9.999, and then I want to subtract 0.999. Let me 33. Okay, fine. And then E, my E is going to be 1. Excuse me, minus 0.001, and I want us to have an F. Our F is going to be 0.4 minus 0.9, and then we're also gonna end up having a G, and then our G is going to be 2.25, and then you're subtracting 5.75. So that's what I want us to do under subtraction. Hopefully we will still be within time to finish this. If we finish it, of course, we go to multiplication, and from multiplication we go to division and see how far we can actually go. Okay, for this one here, what you actually do is very simple. So you do the same thing here. You're gonna end up having 0.9, you write it as it is, and then you place a dot below this dot, and then after that you write the number that is after the decimal and the number that is before that point or that dot, and then we have a minus, which means we have a minus there. And then you ask yourself, what is 9 minus 4? 9 minus 4 is just a 5, a dot and a dot is just a dot, 0 minus 0 is just a 0. So we have 0.5, or you can test it, 0.9 minus 0.4, and then you have 1/2, and 1/2 is just 0.5. And then for this one you do the same thing. So the answer you're looking for here is 0.5. And then here you have 5.75, and then you take this dot as it is, it must be below this dot, and then this number after you write it as it is, 2 must be in line with the first number and 5 must be in line with the second number, so that if there is another number, we know where it is. And then we write this that is below. You have a 2 and then you have a minus there. Now, what is 5 minus 5? 5 minus 5, we know that is going to be a 0. 7 minus 2, we know that is going to be a 5. And then 5 minus a 2, we know that is going to be a 3. And what is important here, because this 0, there is no number that is non-zero following it, we can say that this is just the same as 3.5. You can omit the 0. It's not a biggie. It's not a biggie at all, so you can omit it. So here you will end up having, if you wanted to test it, 5,75 and then minus 2.25. So you end up having 7/2 or 3,5. So that's what this thing is. And then after that, we are actually doing this one here. Which one am I going to give you as a classwork? Want to see? Okay, I am going to do this one here, and then after doing this one, I want you to do this one here, and then after doing this, try and do this. After doing that, try and do this. Try and do all the remaining ones here. This is how we are going to do this. I want you to write it in this format. And then after that, just write in a piece of paper, and then you can take a screenshot and send it in our WhatsApp and see what we are actually having. So here we are having 3.5. You write it, and then you write this dot as it is here, and then you write the numbers after. So 7 is the first number, and then we have 5 after, and then before we have 1, and then you have a minus there. So how do we do it? Here we have nothing here. There is nothing that is here. So if there is nothing, we place a 0. Remember that we said 3.50 is the same as just 3.5. So we can add a 0. It's not going to actually cause any problem. And then after that, we say 0 minus 5. How many 5 out of 0 we can take out of 5 of 0? You can see that you can't do that anymore. So this 0 is just gonna smile at you and say, hey my friend, I have nothing to offer you, so give me some time and wait for me here. I am going to borrow what you need from my neighbor. So this 0 here is going to come and borrow 1 here. So here, if I have 5 and I'm taking out 1, what will be left here will be a 4, and then I'm gonna end up having this one. So after this 0 came to this 5, taking out a 1, this 5 ended up becoming a 4. And then after that, that 1 is actually given here, is here. And then now that I have this one here is because this one is borrowed here, and the position between these two is not the same. So I am not going to say this is 1 plus 0. That's not the case here. So what I'm actually doing here, when I'm placing this 1 here, this now is actually a 10 now. So you have 1 and a 0. We know that 1 and a 0, this is 10. So that is what is happening now. We don't add the 1. We place it here so that this one becomes a 10. So 10 minus 5, we know that is going to be a 5. And then 4 minus 7, we can't do anything of that nature because 4 is less than 7, so we can't. So this 4 is saying, wait here my friend, I am going to go there and borrow something. So it comes here and borrow a 1, and then once I take a 1 here, I will be left with a 2. And then once I have a 2 here, that 1 is going to be placed there. And then now I have a 14. So this is 1, 4. So this is a 14. So 14 minus 7, I am actually going to end up having a 7. And then I have a dot there. 2 minus 1 is just a 1. So this is what we are actually supposed to be having. You can test it here. We can test it here and say, okay, we are having, what was this? 3.5 and then minus 1.5. 1.75. So the answer we are getting here is 7/4 or 1.75. So that's how we are actually getting this. And then after that, I want you to try and solve these remaining ones. And then I'm going to give you about 3 minutes because this is actually not that deep. And then you can send your solution in the WhatsApp group and see if we are actually getting something here. So what is basically happening here, guys, if your network, sometimes it's the network that is not stable. So if the network is not stable, what is going to end up happening? You're not going to see my screen because it's still loading. And also, Teams, it takes time to load. Even in front of me, I have two screens. There, I have my phone. I logged inside with my phone. And then I also have a computer. So in my phone, I can see that it's actually taking time to load, but it's still showing the screen. But if your network is not that stable, that is why I usually record this lesson, so that if it happened that you were affected, you can watch it again, right? So let's see. I'm just gonna give you 3 minutes, and then at 1:46, I'm going to start doing this. But I want to see someone posting the answer here in the WhatsApp, in our WhatsApp group. I'm waiting. Anyone with the answer, just post the answer there. I want to see the answer. Okay, I can see it. Okay, this one is fine. Yeah, just if you are not getting this one, then yeah, anyone who can post the next problem. This one is sorted. It's fine. Okay, this one is 0.99. Okay, this one is also fine. Let's see someone else. Guys, you know this stuff. I think we need to just jump these decimal things, and then you just go straight to finance, which is the main thing that you're supposed to know if you're doing auditing. You know these things. We are just wasting your time. You are ready. I can see that you are actually ready. Okay, let us actually do this. Let's just do this. Let's do this here. Okay, what we did here, we just said, I'm just gonna try and be faster because I can see that you're getting this thing. So here you write this as it is. You have 9, and then you have 9.999. You have 9.999. You can see the answers. You're getting this. You have 9.999, and then after that, you want to make sure that this point here is there, and then the numbers that are after, you have a 9, you have a 9, and the number before is a 0. So 9 minus 0, 9 minus 9 is a 0. 9 minus 9 is a 0. We have this minus here. 9 minus 9 is a 0. 9 minus 9 is also a 0. You have a dot, and a dot is just a dot. 9 minus 0 is going to be a 9. And you know that 9.000 is just a 9. So the answer to this is just a 9. So you usually get some mark for writing this in this particular format. And then for actually doing the calculation, sometimes I say that, oh, you know what is 9 minus 9, I give you a mark. You know that, okay, 9 minus 0 is also actually a mark. And also having this, you can end up getting a full handful of marks. And then sometimes, if I am fair, I can also give you a mark for that 9 there, for knowing that having these extra zeros, you get that. But if it's a multiple choice, it's just a multiple choice, you know the multiple choice. And then for this one here, we notice that this is the same as 1.0, because this one is the same as 1.0. I can add as many zeros, it's not going to add anything. I have 3 numbers after the decimal point, so I add 3 zeros here, and then minus 0.001. And then of course, for knowing this thing here, I usually give you some mark there. Let me give you a red. I give you a mark, and then after that you rewrite that in a tens and units form. So you write this as it is. You have 1.000, and then this point you want it to be below this point, and then you have 001 here, and then you place a 0 before, and then you have a minus that is here, and then you say 0 minus 1. I can't do it, so it cannot be done. So this 0 is just gonna say, wait here, my friend, I'm going to borrow from my friend. My friend is a good friend. So the very same thing that usually happens with you when you have your 5,000 NSFAS. What you usually do, if your friend is actually in deep trouble and now is borrowing the 5,000, all the 5,000 that you have, all you need to do, you just need to be a good friend and borrow your friend your 5,000. You'll see what you're gonna eat, guys. You don't have to worry. God is going to provide. So here, because it has nothing, so it's going to come here and borrow something. But this one have nothing to offer too. So this 0 is saying, wait here, I am going to go there and borrow something, right? So when it comes here to borrow, it finds out there is nothing, and then this one is saying, wait here, I am going to borrow from this one here. So it ends up borrowing a 1 here. Once I take this one out, I will be left with nothing. So there is nothing there. I mean, if you're borrowing your friend your whole NSFAS, you will be left with nothing, and wait from God. God is going to help you. And then after that, you take this one that you borrowed here, you place it here. So once you place it here, now you end up having a 10. But this one here did not want the 1. The 1 was needed by this one that it was borrowing from here. So this one is saying, okay, I have 10 of things now. I am going to give you 1. So when this one is giving it away, 10 minus 1 is going to be a 9. So this one is going to be placed here. And then this one did not want a 1. This 0 is the one that needed a 1. So this one is going to borrow this one here. And then because this is a 10, we'll be left with a 9. And then 10 minus 1, we know that it is a 9. 9 minus 0, we know it is a 0. 9 minus 0, we know... No. 9 minus 0, we know it is a 9. 9 minus 0, we know that it is a 9. And then we have a dot there. 0 minus 0 is just a 0. So that is what you are actually having here. And then the next thing that you do for this one, of course, anyone who have tried this one, just post here. I just post on our WhatsApp. I will see if you got it right or not right. Just post it here. I want to see the solution. With a calculator can always tell us what is the answer. So the answer is not that important. What is important is the steps. Anyone who have an answer? Thank you, Sapokaz. Anyone who have an answer? Any different answer? Let me see this. Or you did 2.4 minus. This one is 0.4. Don't cheat the process. It's 0.4 minus 0.9. Please do it again. 0.4 minus 0.9. Please don't cheat the process. Don't want a 2. 0.4 minus 9. Thank you, Boy Dumelo. Then we can proceed. I think this is what I wanted. I wanted to... Something is missing here, but it's still fine. Okay, let us proceed. I think this is actually fine. Let me just write this homework and then be done. We have 04, and then here we'll have 82.5 divided by 82.5 divided by 4.125. So these are the questions that I have for you. I want you to go, when you're going home, try and solve this and see what you are actually going to get. And then when we are doing our next lesson, it will actually be based on actually multiplication, division of decimal numbers. So basically what is happening here, you will find out that you are actually having a 0.4, and then you want to write this, so you place a dot here, and then after that you're gonna end up having a 9, because we have a 9 after the decimal, and then you have a 0 before the decimal, right? And then you have a minus there, and then you want to subtract here. So basically here you have a 4, and then you're gonna say 4 minus 9. You cannot subtract 9 from 4, so you're supposed to go here and borrow. So because you cannot, here there's nothing here. So if there was a 1, you could have if there was a 1 here, you could have borrowed that one, and then you can place it here so that you can subtract. But the issue here is that there is nothing here to borrow from. this. So what you do in that case, if you cannot borrow anywhere this side, or when you are trying to borrow something from this side, so you end up changing this whole thing instead and say that, okay, because I cannot subtract 9 as 0.9 from 0.4, I want to start by writing 0.9 instead and then subtracting 0.4 from it. So here I have a minus, this was the minus, and then here there was no minus there. So what you do then, because this number is bigger than that number, so whatever you are going to get here is going to be a negative. And then if it is a negative, then we are fine. You say 9 minus 4, and then you end up getting a 5, and then you place a dot, and then 0 minus 0 is just a 0. That's how you end up getting this whole thing. And then when it comes to this one here, of course you do the same thing here. You have a 2.25, and then you place a dot, you have a 7.5, and then you have a 5, and then you have a minus. You can subtract here, but you can't subtract here, so you end up borrowing a 1, and then you're left with a 1, and then you will end up with a 12. Minus this, you will have something. But when you're trying to subtract here, you can't do that. So in order for us to actually move forward, you end up not doing it in this particular fashion, because this number that you are having here is actually bigger. So you start with this big number, you have minus 5.75, and then the dot is there, and then you write 25, and then you have a 2 there. And then you take the sign of the bigger number, because we couldn't subtract because this one was actually bigger. So you take the sign of it, and then after that you say 5 minus 5, it's a 0. 7 minus 2, it is a 5, and then this and that, we have a dot. And then 5 minus a 2, you are actually having a 3. You can test this with a calculator, that if you have 2.25 minus 7.75, what are you getting? So you get that. This is a 5, not 7. What am I doing now? This is supposed to be a 5. So it is that, and then you change it, you get a 3.5 or that. So that's how you actually doing this whole thing. So what I'm expecting from you in this particular homework, anyone who's not getting this, please you can just unmute yourself and then say there is a part that you're not understanding. But what I want you to understand in this, because the time is already up here, if you wanted to actually, for this homework, if you wanted to actually solve this homework here, the first thing that you need to do, convert this to a fraction and this to a fraction, and you know how to multiply fractions, and then you convert it to a decimal. The same thing that you do here, and then it's the same thing that you do here. It's simple as that. It's not a biggie at all. I think we're gonna end there. Try and copy these questions, and then try and solve them and see if you're getting the answers, and see if the method that you're using is actually working. If it's not, if it's working throughout these problems, then it's fine. If it's not working, then it is time for you to actually learn more about the tricks that we'll use to actually solve this. The reason I'm giving you this beforehand is because there are several ways to do this, different methods. I'm gonna choose one, and for you, if you have a different method, it's fine. But when we open, I think around from the by the 5th there is a graduation, so I'm not available. And then let's say from the 6th onwards, so if you are looking for the 6th and then onward, I would be in my office. If you think maybe your method you think is working is different from this, it's still fine, you can consult and then we'll look into it. But if it's actually not a right method, then I will tell you that it is not the right method. So I think we'll end there, and thank you for attending. Any questions so far? Just unmute yourself and tell me if you have a question or not. Someone was raising a hand. I don't know who. Just unmute yourself and say what if you have a question. Ask your question. Okay. In the absence of questions, class dismissed.